Hi, I'm Justin Luis R. Morales from BSc 101 Science, and today we'll be talking about viscosity. What really is viscosity? Viscosity is the resistance of an object or substance to flow. The slower a substance flows, the more viscous it is. Now, in viscosity, there's is the cohesion or the cohesive force. This is a property of a molecule to be attracted to one another. It is strong in solids and it is weak in gases. In liquids, they slide. What do I mean by they slide? Because the molecules in a liquid is strong enough to hold the liquid molecules together, and they are weak enough to slide unless they are stressed or a pressure was exerted to the liquid. In liquids, the molecules are also further apart than solids. That's why they are able to change their shapes accordingly depending on the container. Viscosity in liquids is the measure of resistance to gradually change if applied with a stress. Here you can see arrows pointing down. That is the stress that is applied to water, and its water molecules are going in either of the directions. This means that if a stress is applied on a particular substance or fluid, or it will react accordingly depending on this applied force. And according to the fluid dynamics, which we have discussed last time, the amount of pressure exerted on a fluid is the same all throughout the substance. Viscosity varies from substances. That means every substance, particularly in liquids, have their own viscosity. Consider this following example. For example, we have honey and water in a room temperature of 25 degrees Celsius, and we pour those substances in an inclined plane. Who do you think will win first and reach the bottom? The water, right? So why? How about the honey? Why honey flows slowly? To further understand more, here's a table. We can see and compare that water and honey have different characteristics. In terms of flow rate, the water has high flow rate in compared to honey with low flow rate. Next is viscosity. In water, it is low viscous in comparison to honey, which has high viscosity. Because the water is low viscous, it has weak cohesion force in comparison to honey, has a high viscosity and a strong cohesive force. And as I have said, the slower the substance flows, the more viscous it is. And as I've said, the slower a substance flows, the more viscous it is. Now, viscosity can be also affected by temperature. Why is it so? Because if, for example, if I pour a water in a kettle and set it on fire, the water reaches the 100 degrees Celsius, its boiling point, and therefore it turns into gas, as we all know. The same thing happens with raising the temperature of a viscous fluid or substance. Same thing happens when heat is applied to a viscous fluid. Molecules gain energy, move apart, and the cohesive force or the cohesion, the attraction that holds molecules together, becomes weaker. So for example, the honey again, the orange color represents the honey in a room temperature of 25 degrees Celsius. However, the red color represents honey in 90 degrees Celsius. Warmer honey in 90 degrees Celsius tends to flow faster than honey on room temperature. It is because the molecules in the warmer honey has become more active and gained energy, and therefore the cohesive force became weaker. A force of 2.1 newtons needs to move the upper plate at a speed of 0.25 meter per second. The area is 0.5 squared meters in a distance of 1 centimeter. Calculate the coefficient of viscosity of the fluid and calculate its velocity gradient. All we need to do is to substitute it in the formula. Here's the formula. Force is equals to the coefficient of viscosity multiplied to the area multiplied to the quotient of the speed over distance, denoted by L. Now, observe that we have all the given informations. All we need to do is to simplify all of it. It is important to convert the centimeters to meters first, because meters is the unit that we need to cancel out things. Okay? By substitution, we have 2.1 newtons, the unknown of coefficient viscosity, 0.5 meters squared, 0.5 squared meters, and 0.25 meter per second over 0.01 meter. Now, we reach this simplification. We are given with 2.1 newtons is equal to coefficient of viscosity unknown times 12.5 squared meters times 1 of a second. Since the coefficient of viscosity is unknown, we need to cancel both of these values in this side, and so we can get the with 2.1 newtons over 12.5 squared meter 1 of a second. The answer would be 0.168 Pascal second as our coefficient of viscosity. Pascal second become the unit of the coefficient of viscosity. Calculate this formula right here so that we can isolate the coefficient of viscosity. We will be having this formula. Coefficient of viscosity is equals to the force in newtons, the distance in meter, area which is in squared meter, and velocity or the speed which is in meter per second. Now, after cancellations, it will be transformed like this: Newton second over meter or squared meter. Now remember that Pascal or a Pascal is equals, or pressure is equals to the force over area. The force is in newtons and area is in squared meter, or simply pascals. Therefore, what we are given here is newtons. What we have here is newtons over squared meters 1 of a second. So by simplifying, newtons over squared meter is just a Pascal. So it turned to be Pascal second. And the final answer is 0.168 Pascal second. As for the velocity gradient, it is just the speed over distance, or this formula right here. So by substitution, we can also get it, and we have it as 12.5 meters squared 1 of a second. So that's it. Thank you.